Okay, so we're going to continue with taking roots of polynomials, but now we're going to move past perfect square roots. So the root of a polynomial is a number or variables that are multiplied by itself, the number of times the nth root shows. So it doesn't have to be square root or cube root. I know in some of the previous videos we did fifth root. So it all just depends on the root that they're asking you to find. So we call that the nth root because it can be any number, 2 or bigger. So if it is not a perfect square, then we're going to break it down into its factors that are perfect squares, if possible. So because I can take the square root of a perfect square, but I can't take the square root of a non-perfect square because that'll end up with a really funky decimal that we don't want to deal with. And Alex is not giving us any rounding instructions. So we don't just simply type in, 45 here and take the square root of it and see what we get. That's not going to work. So with this one, we're going to look at the square root of 45. So I'm going to break it into its factors. So I'm showing you that it's 3 root 5. That's the answer. And the reason is because I'm breaking it into 9 times 5. Well, 9 times 5 is 45. 9 has a square root of 3. And then 5 does not have a square root, so it stays under the square root sign. Okay, so it's just breaking it apart. And I know we've done this, in previous chapters before. We're just kind of reviewing it again. So this idea where we're just breaking it apart into cubes or into whatever root, sorry, not cubes, this time it's squares, into whatever factor I need to get that root out. So if I'm looking for squares, then 9 is definitely a good number. And then for the variable, we can use that idea where we can expand it into the groupings of the root. So, the squares, x squared, I can see I have 4 of those because 2 times 2 times 2 times 2 is what gets me, or 2 plus 2 plus 2 plus 2, sorry. Those are exponent rules. When you're multiplying a base with the exponent, you add the exponents. Or I can simply just take the 8 that I know I have 8 of them, and I can divide by the root, which is 2. So I have 4 of them total. If I don't get a whole number there, that means that there's going to be some left over. In this case, I'm going to end up taking them all. So you can see up here I have the 3 that I had out in front here, and I also have the x to the 4th power with it. They both get multiplied together, which just means we squish them. The only thing left under the square root sign is that 5. Everything else came out. All right, let's go ahead and take a look at another one. So now in this case, we're going to take the 4th root of 162. Okay, so we're going to break 162 down. So you can see I'm showing you the answer first, and then I'm showing you why. So when I break down 162 into its prime factors, I get 3, 3, 3, 3, and 2. So I can say, 162 does divide by 3, and then that answer divides by 3. That answer divides by 3. That answer also divides by 3. So I can keep breaking this number down into its prime factors. So definitely go through and, break down the number because that's not always the easiest thing to see. And then I want 4 of them. Remember, now I'm grouping it by 4. Square root is a number multiplied by itself 2 times. Well, 4th root means it was multiplied by itself 4 times. So I can see I have 4 3s. So that means the 4th root here is 3. I get to take 1 out for every 4 that I can group. If I can't group it, it just stays. And remember, I should have actually put that here as well. Whoops. There should be a 4 because this is not a square root. If there's no number there, that means square root. That's just an automatic assumption. So that's why you can see in my answer here, I did put a little 4 there. I just forgot to also repeat it on that one. So just keep that in mind. It's the 4th root, not the square root. We only leave that off if it's a square. All right, so that's the idea of finding the square root of a non-perfect polynomial. All right, I hope that helped, and I will see you in the next video.